Hi, I'd like to do a short video about playing with vectors and scalars, or the difference between vectors and scalars. And I think for most of us in physics classes, when we're talking about vectors versus scalars, the emphasis on that vectors can have magnitude and direction, but scalars don't have any direction. So classic example, if you have a velocity of say 10 meters per second east, the magnitude or the size of that vector is 10 meters per second. The direction is east. But if you're talking about the speed of an object, the speed might be, for example, 15 meters per second. But speed does not include direction. Just like when you look at the speedometer in your car, it doesn't tell you what direction it's going. The other classic thing about vectors is that you can show a vector, you can represent a vector by using an arrow. And clearly for a scalar, if you don't have any direction, you couldn't use an arrow. Like if you say something has a mass of 10 kilograms, you can't really use an arrow for 10 kilograms because that mass doesn't have direction. The other thing is, here would be an example of a vector. Here's vector B. Vector B could be resolved into components. In this case, B looks like it goes 3 to the right and 4 up. So it would have an x component of 3 and a y component of 4, and you could draw those in. If we go and take a look at how this looks for VPython or for Glowscript, my line on 5, it says A is a vector, and I should say, or is a scalar. So really, I don't think scalar is a term in Python or in Glowscript. I think they would just say it's a number. We can get a little bit later on into the different types of numbers that Python recognizes, but right now we'll just say that A is a scalar, like it's a regular number. I don't think the output of line 7 is going to be too much of a surprise. Looking at line 10, it says B is a vector. B is, and if you'll notice, it's actually the same vector because that 3, 4, 0, that's the same as vector B here goes in the x direction 3 and in the y direction 4. It's really tough on paper to show the z direction, so I just kept that one as 0. So I wonder how line 12 is going to work out when it says print what that is. So I'm going to run that. I'm going to use the Control 2 way to run so that it goes in a new window so we can still see the code on the left. So there it says A is 5 and B is, so we see that 3, 4, 0 way of running things. A couple of things I wanted to talk about yet in my video is how to refer to each component. Like, so let's say if we wanted to change some component of B, and I think we've done a bit of this already. I can refer to like b.x to refer to that x component, which is currently 3. So if I say that now, let's make it 5, and now I print, I'll try this again, if I print B, let's see what happens here. So I can say run the program, or I'll do Control 2 again. So it was 3, 4, 0, and now when I changed b.x into 5, that's what I get. Okay, and we can do math with that as well. So we could, print b.x plus 3. I guess I'm getting into how can we do math operations. So I just said that b.x was 5, so 5 plus 3, it should print an 8 at the end of that. Oh, did that wrong. Let's try this again. I'll do the Control 2 thing. Yeah, we get an 8. Okay, so let's talk about some of the math operations we can do. So we can do regular math. So if I say, let's make a couple of, we already have a vector and a scalar. So can we add them? So what if we say print A plus B? So what would it look if we add 5 with, what was it again? You know what, I'm going to get rid of these lines here, so I just have that original 3, 4, 5 there. So I'll print that, and let's try running it. Looks like we get an error. I'll make this window larger so that we can see. It says cannot add a scalar and a vector. Okay, so we can't do that. So not allowed. So I'm going to get rid of that line altogether. Maybe I'll just hashtag it out. Won't work. What if we multiply? Print A times B. Oh, no, we don't want the hashtag for that one. Okay, so I'll do the Control 2 feature on here, open in a new window. Maybe I'll shift that to the right. Okay, this is interesting. So now we get 15, 20, 0. So when I multiplied 5 times that vector 3, 4, 0, you'll notice how it works. It multiplies that 5 times each of the components. Kind of makes sense why we use the word scalar, because what we've really done is we've scaled up that vector. What about, I wonder, let's make a new vector here. Let's do a vector C equals vector 2, 2, 2, something like that. I wonder if we can multiply, print. So my original vector is B, multiply two vectors together. Let's try that one. Oh, so it says, what do we get here? Cannot add, oh, A plus B is a problem. Oh, I think I got rid of, what did I do here? I got rid of this hashtag. Didn't want to do that. Okay, so C equals 2, 2, 2, 2, and I'm multiplying. Okay, so line 20 is two vectors multiplying together. Let's try this one. Cannot multiply a vector by a vector. So far we kind of know. Then we can do all the functions we can do with regular numbers, but we got to be a little bit careful how we're going to be multiplying. We could, multiply the first component of C with the first component of B. Like we could do like print B x times C dot x. That would be okay to do, but we can't just multiply those two together. And we can learn some more about vector operations a little bit later. All right, I'd like to talk a little bit about our example with velocity, and I've added a bit here. In our computational model of constant velocity, we use this x equals v times t plus x0, where x is the position of the object, and v is the velocity, and t is how much time goes by. So when we bring that into our computational model, I guess it's really line 41, where we don't have to say x0 on the right-hand side because that's the old position, and we don't have to say the full time because we're going to use dt, which is our little step in time each time. All right, so I hope that makes sense. Really, this example that I wrote from line 30 to line 43 is an example where I'm using this variable x, which is not a vector, it's just a single value. V is just a single value. You see in line 5, I say we're going to start with 5. And then line 42 changes just the x position of that ball. I'm just going to copy this and then the whole part, and then I'm going to make I'll paste it over here so I can still refer to it. And I'll just highlight this one out so that we're only dealing with the second one. So I can still compare here. So I want to make another example here. Let's change hashtag here. Let's change v to a vector. 2 exclamation marks. So I'm going to say, and I'm going to define this inside of 54, line 54, where it's the ball. And I'm going to say comma. I'm going to say the velocity equals a vector. Now I'm going to say that this ball could be moving in the x direction, it could be moving in the y direction, or even the z direction. I'm going to try to recreate the original one though. Originally this was only moving horizontally, so that 5 is in the x direction. So I'm going to say 5, 0, 0. So that's going to make, if we can make this work properly, that's going to make the ball move in the positive in the x direction. Okay, so I'm going to hashtag out that old one there. My original position, x equals 0, that still works fine. Okay, so line 60, I'm not going to do the advancing separately like that. I'm going to kind of do what I'm doing in line 61. Line 61 was originally where I'm actually moving the ball, and I'm moving it to whatever that position is. So I'm going to rewrite, again, it's this mathematical model again. And x is the position of the ball, but not just the x position, it's the entire position. So if I go like this, that's not going to be accessing just the x value, it's going to be the entire vector where it starts at x, 0, 0. So I'm going to say ball position is going to be equal to, now I need to do the velocity, so it's ball dot, what did I call it? VEL for velocity. times dt plus the ball position. So if this does work properly, I just want to point out I've got this is a vector with an x, y, and a z value. This is a vector with an x, y, and a z value. This is a scalar, which in this case is it's a very small number, 0.01. So this is going to, remember, well, I can multiply a vector times a scalar. This is just going to scale that, each of the x and the y, z values downwards, plus the original position. Okay, let's see how this works. By the way, I made a blue table in here. Oh, of course I've got an error to begin with. It says missing right parentheses on line 55. Okay, let's go check it out. Line 55. Okay, if I put another one in there. Unexpected token name. Table equals. Okay, so we got a lot of stuff here going on. Table equals. All right, what did I do? Well, if I look at that line again, it looks like let's just see if I put that right parentheses in here. Try writing that again. Too many right parentheses in line 55. Oh, I know what happened. When I put the right parentheses, I think I put it in the wrong spot. Let's try it again. Am I going to get my... Yeah, I got my parentheses figured out. Okay, so there's the table. Things are moving to the right, and you see it's moving kind of fast, and it stops there. Okay, so now what the beauty about doing it this system, rather than the old system, is that let's say I wanted to have it moving in a different direction. Instead of moving in the x direction of 5, let's make it go in the y direction of 5. Woo, it's going up. Isn't that cool? What if I want it to go in the z direction of 5? Is z towards me or away from me? I don't even remember. Whoa, it's going right towards me. Isn't that kind of cool? There it went towards my eyeball. You can also do more than one. So I'll make it go in the x direction 2 and the y direction 3. And I'll say run. Oof, and it goes off that direction. That's pretty neat, isn't it? Okay, so just to review a little bit, we learned about the difference between scalars and vectors, and I showed how here it's kind of using a scalar model to do that, where I'm just changing x as a scalar, and here I'm making velocity an attribute of ball, and it is a vector. And then line 61 becomes a little bit more powerful because I can make that velocity in any direction. All right, so I hope that was helpful for you.